Hi, I'm Bob. Welcome to the Solutions to Microeconomics course that I hope can help you understand the topics well. We will solve the first 6 exercises for the long-run course today. Let's get started. Here is exercise 3.1. The production function is linear for perfect substitute inputs. What is the long-run cost function? For the linear production function, the slope of the isoquant equals the ratio of the marginal product of labor to the marginal product of capital. It is 1. We compare the slope of the isocost lines and the slope of the isoquant. The slope of the isocost lines is the factor price ratio, W/R. If the wage rate is greater than the capital price, then the isocost lines are steeper than the isoquant. The corner solution occurs on the k-axis. The firm only uses capital to produce. So the production function is Q equals K. The cost identity is C equals W times L plus R times K equals R times K equals R times Q. This is the long-run cost function. If the wage rate is less than the capital rate, then the isocost lines are flatter than the isoquant. The corner solution occurs on the labor axis. The firm only uses labor to produce. So Q equals L. The cost identity becomes C equals W times L. Substituting L equals Q, we have the long-run cost function. Let's try exercise 3.2. A bottling company uses 2 inputs to produce bottles of the soft drink sludge. Bottling machines K and workers L. The isoquants have the usual smooth shape. The machine costs $1,000 per day to run, and the workers earn $200 per day. At the current level of production, the marginal product of the machine is an additional 200 bottles per day, and the marginal product of labor is 50 more bottles per day. Is this firm producing at minimum cost? If it is minimizing cost, explain why. If it is not minimizing cost, explain how the firm should change the ratio of inputs it uses to lower its cost. We can use the last dollar rule to determine whether the firm is minimizing cost. If it minimizes its cost, the last dollar spent on labor results in as much extra output as the last dollar spent on capital. The cost of capital is $1,000 per machine. The wage rate is $200 per worker. The marginal product of capital is 200 bottles per machine. The marginal product of labor is 50 bottles per worker. The marginal product of labor divided by the wage rate is the marginal product of the last dollar spent on labor. It is 1/4 bottles per dollar. The marginal product of capital divided by the cost of capital is the marginal product of the last dollar spent on capital. It is 1/5 bottles per dollar. Since the last dollar spent on labor produces more output than the last dollar spent on capital, the firm is not minimizing its cost. It can use more labor and less capital to lower its cost to produce a given level of output. The graph shows that the firm is at point A now. As it adjusts its inputs and moves to point B, it minimizes its cost. Let's do exercise 3.3. You have 60 minutes to complete an exam with 2 questions. You want to maximize your score. Toward the end of the exam, the more time you spend on either question, the fewer extra points per minute you get from that question. How should you allocate your time between the 2 questions? I will allocate my time between the 2 questions so that the last minute I spend on either question gives me the same benefit. The extra points per minute I get are diminishing as more time is spent on the question. That is, the marginal benefit of time spent on the question is diminishing. The strategy is similar to the last dollar rule for the firms to allocate their resources between 2 inputs to minimize their cost for a given output level. Here, we allocate our time between the 2 questions to maximize the scores for a given time. Let's solve exercise 3.4. Suppose that the government subsidizes the cost of workers by paying for 25% of the wage. What effect does this subsidy have on the firm's choice of labor and capital to produce a given level of output? We use the isoquant isocost diagram to analyze the problem. After the government subsidizes the cost of workers, the firms can pay the workers a lower wage. The relative price of labor to capital drops with the subsidy on workers' wages. The slope of the isocost lines is the relative price of labor to capital, W over R. The isocost lines become flatter from isocost 1 to isocost 2. The isoquant is not affected by the subsidy. Assume that we have an interior solution. By the tangency rule, the cost-minimizing combination of labor and capital to produce a given output level, Q bar, moves from A to B on the isoquant. The firm uses more labor and less capital in production. Let's jump to exercise 3.5. The All-American baseball is made using cork from Portugal, rubber from Malaysia, yarn from Australia, and leather from France. And it is stitched by workers in Costa Rica. To assemble a baseball takes 1 unit of each of these inputs. Ultimately, the finished product must be shipped to its final destination, say Cooperstown, New York. The materials used cost the same in any location. Labor costs are lower in Costa Rica than in a possible alternative manufacturing site in Georgia, but shipping costs from Costa Rica are higher. Would you expect the production function to exhibit decreasing, increasing, or constant returns to scale? What is the cost function? What can you conclude about shipping costs if it is less expensive to produce baseballs in Costa Rica than in Georgia? Because to assemble a baseball takes 1 unit of each input, the production function exhibits constant returns to scale. When all inputs are increased by T times, the output increases by T times. The corresponding cost function is as follows, where W1 is the unit price of materials, W2 is the wage rate of workers, and W3 is the unit price of shipping. We know that the production cost in Costa Rica is lower than in Georgia. The materials used cost the same in any location, so W1 is identical in either place. The shipping cost from Costa Rica is higher than from Georgia, but the actual shipping cost is lower than the savings in the labor cost. Let's try exercise 3.6. A firm has a Cobb-Douglas production function where the sum of A and B is less than 1. What properties does its cost function have? The property of a cost function refers to whether the cost function exhibits economies of scale or diseconomies of scale. From the textbook, we know that returns to scale are sufficient condition for economies of scale. In other words, if a firm's production function exhibits increasing returns to scale, the cost function will have economies of scale. If the production function has decreasing returns to scale, then the cost function will exhibit these economies of scale. In this exercise, the firm's production function has decreasing returns to scale, so the firm suffers from these economies of scale. Or we can address a general case in 4 steps. That is, we can derive the long-run cost function from the production function and then figure out its property. In the first step, we derive the expansion path equation, in which we can express k as a function of L. We use the tangency rule in this step. In the second step, we express labor and capital in terms of output. We substitute capital in the production function and write output as a function of labor. Then we write the inverse of the function. We express labor as a function of output. Capital can also be expressed as a function of output. In the third step, substituting for labor and capital in the cost identity gives the cost function. Cost is expressed in terms of output. In the fourth step, we find out the property of this cost function. We write the average cost and then find the derivative of the average cost with respect to output. It is positive. The average cost rises as output increases, so the cost function exhibits these economies of scale. Thank you for watching this video and subscribing to my YouTube channel. See you next time.